So as I said, then this is the corona that you see when the moon is blocking the sun. You see this nice white wispiness coming off the sun, and that's the corona. Completely invisible because the sun's too bright, unless there's an eclipse. So one of the questions, of course, that usually comes up about now is how is it that the moon can even block the sun? And the reason for that is some of the sizes that I showed you on previous videos earlier in the course here, where, you know, if the sun is something like this big here on this scale, the moon would probably be something like that little dot, or even smaller, something like that. So how is it something like this small can block something that big? And well, you know that the sun is really big, but of course it's far away, and the moon is really small, but it's relatively close to us. In fact, the numbers work out in a very eerie way, which I'll show you right now. So I just want to address how is it that the moon can even block the sun. Well, it sort of goes like this. Just let me put a couple numbers for you up here. Okay, the sun here, that's going to be a little too wide. The sun here is about 93 million miles away from the Earth. And it has a radius of about 430,000 miles. Okay, so this is the distance, and this is the radius here. Okay, then you have the moon, the good old moon here, which we love so much here. The moon has a distance of about 250,000 miles. Remember, we discussed that in terms of cars and wondering if the moon is really even that far away. And the radius of the moon is about 1,080 miles. Okay, so you can tell the difference in the numbers here. Much different size, right? But also much different distance also. So the funny thing about it is if you do this, is if you look at the ratio of these two numbers here, 430,000 divided by 93 million, you get a number of about 0.004. Okay, just do a little division there. And you won't believe it, but if I take 1080 and divide that by about 250,000, I get the same number. So these numbers here are for the sun, and these numbers here are for the moon. You can just remember that. But I get the same number here when I take that ratio, not ration, ratio of, let's see, I guess we're going to call it the radius to distance. I get the same number. So what that means then is that in the sky, the sun and moon are the same size in the sky. And let me just fix that up here. Not same size, same, I just want to choose the same apparent size. We know we're not the same size. They're a vastly different size, but same apparent size, because the sun is large but far away. The moon is smaller but closer. And so if you're on Earth like this, here you are on Earth, and if this is the moon right here, and this is the sun way over here, I'm not choosing any colors, the sun, the moon like that, if you started to wonder about the angles that I just sort of drew out here, then this sort of angle here that reaches the sun and the moon, lines didn't quite work, did they? Let me try that again. I think I can do it this way. The line here that goes all the way to the sun, and the line here goes to the moon all the way to the sun, it's a little better, or about the same. And so that's how the moon ends up, the small moon ends up blocking the large sun. And the cool thing about this also is a lot of planets have moons that we've discussed here, but the Earth is the only planet in the solar system where this happens. So you have to put a few exclamation points and a happy face after that. We are the only planet in the solar system that has this funny ratio between the sun and one of our moons, that the size in the sky, the apparent size in the sky, is exactly the same. So in other words, we're the only planet in the solar system that ever sees total eclipses. And I just think that's pretty cool. So you have to be on Earth if you ever want to see the corona. Isn't that cool? Okay, we'll wrap up in the next video.